Now, in many fine-tuning job of large language models using Hugging Face transformer library, you will see this particular line, tokenizer dot pat token equal to tokenizer dot us token. So why I am setting the pat token equal to us token? First, note that pat token is used to fill shorter sequences in a batch to match the longest sequences length, ensuring uniform input size for model processing. Now, with the line tokenizer.pat token equal to tokenizer.us token, we are effectively using the same token for padding and end of sequence, that is the US token. And this is a technique sometimes employed to reduce the complexity of the tokenizer's output space, especially in generative models where managing different spatial tokens can impact the model's performance. Essentially, this approach uses one token to serve two purposes: indicate the end of meaningful content and fill space in shorter sequences, that is padding, to match the length of the longer sequence in a batch. Now, the end of sequence token, that is a US token, on the other hand, is crucial for models, especially in a task like language generation, signaling the conclusion of a textual input. By setting the pat token to the same value as the US token, you streamline the model's understanding and processing of sequence ends and padding in a consistent manner. This is particularly useful in models where the distinction between padding and end of sequence needs to be minimal to simplify the model's decision-making process on when to stop generating text. In practice, this configuration suggests that the training regime for the model in question is designed in such a way that the presence of these shared token at the end or in the padding does not confuse the model. For example, when a sequence ends and is followed by this token as padding, the model learns to recognize the end of content and treat subsequent tokens as irrelevant, or at least not let them influence the generated output significantly. Now, let's consider an example scenario to understand in detail. So in this example right here, we are training a language model on a set of sentences for a text generation task. We will look at how using the same token for padding, that is pat token, and end of sequence, that is US token, can be beneficial, particularly when training data and model architecture are appropriately configured. Suppose we have these following two sentences here, that is hello, how are you? This is one sentence, and another one is I am fine. So when tokenized and prepared for model training, each sentence might end with an US token to signify the end, like this, hello, how are you, and then an US. And again for sentence 2, I am fine, and then an US, because that's the end of the sentence. Now, for padding, for batch processing, for efficient training on GPUs, sentences are batched together. And if the sentences in a batch are of different lengths, shorter sentences must be padded to match the length of the longer sentence in the batch, or actually the longest sentence in the batch. And that's what we are doing here. So under this first scenario, we with different tokens for padding and US. So I am putting this US here, and then the two tokens need to be there for the sentence 2 because it has got 2 tokens less than the longer sentences. So I have the first as US, representing the end of the content of the sentence, and then just to match the length, the pad token here. So here the strategy is that different tokens for padding and US. So here the pad is clearly distinguished from US, means the model must learn to ignore pad token, which can add complexity to its training, as it must differentiate between two types of non-content bearing tokens, one that signifies the end of the content and one that is purely for maintaining consistent input size of sentences. Now, the next situation is, that is the next scenario, which is when pad token is equal to US token, which is exactly what we are using here. That is tokenizer.pat token equal to tokenizer.us token. So this is the situation I am looking at in here. So here both sentences would use the US token for both padding and end of sequence. So here I'm putting US because that's the end of sentence. And here for sentence 2, I'm initially putting US, signifying the end of content. And then another US, this is actually representing the padding to make the length of the two sentences same. So in this second situation, the advantages are that first is model simplification. So the model only needs to learn to handle one special token, that is EOS, that can indicate the end of meaningful content. This reduces the number of rules the model needs to learn, potentially speeding up training and reducing the complexity of the model. And also consistent handling, that is because every sequence ends with EOS, whether it is actually the end of sentence or just padding. This consistency might help in some architectures where the handling of sequence ends and padding needs to be streamlined. So means in this setup, that is in the second situation, the model is trained to understand that the first EOS it encounters might indicate the end of meaningful content, and any subsequent EOS tokens are irrelevant. This is contingent on the model's ability to contextually discern that subsequent EOS tokens after the first are not part of the genuine content. This configuration works best in scenarios where the sequence end does not have to be sharply distinguished from padding during the generation task, as the model learns to treat any output after the first EOS as not generating meaningful text. This can be particularly useful in model designed for tasks where precise control over the end of sequence is less critical, or where post-processing can easily trim padded output. So in other words, this means that this configuration, pad token equal to US token, assumes that the model has been adequately trained to interpret the US token robustly, not only as an indicator of the end of a valid sequence, but also to ignore it when it appears as padding. So the model should have learned very well the contextuality as to when the token is signaling an end and when it is just padding. If the model does not learn the distinction effectively, it might lead to errors like prematurely ending generation or including unwanted padding in the output. So if you are noticing issues like abrupt sentence ending or inappropriate sequence termination in your model outputs, you might need to reconsider these configuration. One alternative approach is to explicitly distinguish between the EOS and pad token, assigning a unique pad token that the model learns to ignore during training. And this would involve setting tokenizer.pad token to pad, that is ensuring it is included in the model's vocabulary and probably handled during the training process. And if you are working in an environment where distinction between sequence and the padding is crucial, or if you notice problems that could be linked to this setup, you might consider using separate tokens for padding and EOS, ensuring that each has a clear, unambiguous role. This might involve modifying the tokenizer's configuration and ensuring your model's training data includes examples that help it learn to handle these tokens appropriately.